It's nice meeting you once again. Today we'll be looking at the last type of variation, which is partial variation. Partial variation is slightly different from the other three types that we have discussed. In terms of one, there are two constants instead of one, C and K. Then two, these constants are solved simultaneously. So we use simultaneous equation on this method, partial variation. Now let's look at some examples. One, S is partly constant and partly varies. As T. Write this relationship. So let's identify the quantities here. S and what? T. So S is partly constant and partly varies as T. S is partly constant and partly varies as T. If we introduce the other constant, we have one constant here already. It will be S equal to K plus CT, where K and C are constants. Where K and C are constants. Let's look at another example. E partly varies directly as M and partly varies jointly as N and V. Write out this connection. What are the quantities here? E, N, N, and V. There are four quantities. So let's write it out. E partly varies directly as M and partly varies jointly as N and V. E partly varies directly as M and partly varies as N and V. Let's introduce the constants now. We now say therefore E equals K N plus C N V, where K and C are constants. Where K and C are constants. So with these two examples on how we write the relationship between the quantities in partial variation, we should be able to solve any given problem in partial derivation. Now let's see some other practical examples. Yes, you must have finished writing this one, huh? If you are writing. So let's look at number 3. Two quantities P and Q are connected by the relationship P equals C plus KQ, where C and K are constants. If Q equals 60, when P equals 10, and Q equals 240, when P equals 100, find the relationship connecting P and Q. Now let's look at this third example. Let's look at this third example. In this third example, all the work has been done for us. Just like after mommy has gone to market, prepared the ingredient, finished cooking, and put the table on our front, our job is just to eat. That is what you see exactly here. They have done all the necessary job for us. Our job is to eat. Let's see. We are given already that P equals C plus what? KQ. We already been given, no job for us to do that. And we have already been told that C and K are what? Constants. So let's substitute the given values inside to solve for the constants. We are told that when P is 10, Q is 60, and when P is 100, Q is 240. Let's substitute them inside. That becomes 10 equals C plus 60K. That will be our equation 1. Then 100 equals C plus 240K. That will be our equation 2. Now let's use the elimination method to handle this. So equation 1 minus equation 2. 10 minus 100, that's minus 90. C minus C goes natural. We have 60 plus 240. That will be minus 180K. The left hand side is equal to the right hand side. So minus we take minus, leaving 90 equals 180K. Now let's use 180 to divide both sides so that we can look for the value of K. So we now say divide both sides. by 180. Now let me just mention something here. Sometimes this is the right DBS for divide both sides. In mathematics, you don't write it like that. You write it full. Divide both sides by, because the examiner might think DBS means data broadcasting service, or it could be an acronym for any other thing. So in order to clear those kind of confusion out, you write out the full meaning. Divide both sides by. So that's divide both sides by 180. So that is going to be 180k over 180 equals 90 over 180. 180 will take 180 here. 0 will take 0. 9 here 1. 1 here 2. So the value for k is 1 over 2. Yes, we have one of the constants now, k, as 1 over 2. So let's substitute k equals 1 over 2 into either equation 1 or 2 to get the other constant c. Let's use equation 1. Any of the equation will give the same result. Equation 1 is 10 equals c plus 60k. So anywhere we see k, we put 1 over 2. That becomes 10 equals c plus 60 times 1 over 2. 2 here, 1. 2 here is 30. That becomes 10 equals c plus 30. So if we collect like terms, not CLT, write it full. Collect like terms. We collect like terms, we are going to have 10 minus 30 equals to c, which is minus 20 equal to c, which also implies that c equals what? Minus 20. So therefore, c is minus 20, k is 1 over 2. So we know the values of the constants now, c and k. C is minus 20, k is 1 over 2. But remember what they asked us to find. They said the relationship that is connecting the two quantities. The relationship that is connecting the two quantities. So how do we get the relationship that is connecting P and Q? Remember the original equation where we are giving P equals C plus KQ. So we simply substitute the values of the constant here. Substitute the values of the constant here. So now be therefore P equals C is minus 20 plus K is, that's 1 over 2 what? Q. That's the relationship that is connecting P and Q. It's as easy as that. Now, it is not in all cases we will be given an already prepared equation, as in this case we solve number 3. It's not in all cases. Sometimes we will be the ones to generate everything ourselves from the scratch, like going to the market, buying the ingredients, preparing the ingredients, cooking before we start eating. Let's see that kind of situation in example 4. Let's see that kind of situation in example 4. The resistance to the motion of a car is partly constant and partly proportional to the square of the velocity. When the velocity is 20 km per hour, the resistance is 50 Newton. And when the velocity is 30 km per hour, the resistance is 100 Newton. Find for what velocity? Your resistance is 170 Newton, sorry please, 170 Newton. So now let's look at this. Let's look at this. Don't be scared. When students see things like this, they get scared. What am I going to do? This is too much. Don't be afraid. Just follow step by step. You get your destination. It's as easy as eating your best food. Let's look at this. Let's start from the scratch. Identify the quantities. What are the quantities here? Resistance to the motion of a car is partly constant and partly proportional to the square of the velocity. So there are two quantities here, resistance and velocity. So first, let velocity be V. Let's the resistance. All right. We have identified the quantities here. Now let's go again. The resistance to the motion of a car is partly constant. The resistance is partly what? Constant and partly proportional to the square of the velocity. That is it. The resistance is partly constant and partly proportional to the square of the velocity. So that's going to, let's introduce other constant C. That's going to be R equals K plus C E squared. Here K and C are constants. Here K and C are constants. So let's go from here now. Now, when velocity is 20 km per hour, resistance is 15 Newton. So when resistance is 50, velocity is what? 20, and when velocity is 30, resistance is 100. Find for what velocity the resistance is 170. Now, with this complete information for the two quantities, the objective here is first for us to find the two constants, K and C. That was the objective of giving us the values for the two quantities here. So let's substitute them into our relationship. We have R equals what? K plus C V squared. So that is going to be 50 equals K plus C 20 squared, which means which is 50 equals K plus 400C. That's our equation 1. Then also when R is 100, that becomes K plus C 30 squared, which is 100 equals K plus 900C. That's our equation 2. Now let's rewrite equation 1 and 2. Hope you are following up. Yes, I believe that. Let's rewrite equation 1 and 2. That will be 50 equals K plus 400C, then 100 equals K plus 900C. Let's use elimination method. Equation 1 minus equation 2. 50 minus 100, that's minus 50. K minus K goes out, leaving minus 500C. So minus cancel minus here, leaving 50 equals 500C. We divide both sides by 500. If you divide both sides by 500, that would be 500C over 500 equals 50 over 500. 500 will take 500 here. 0 will take 0 here. 5 here, 1. 5 here is 10. So the value for C is 1 over 10. So we know one of the constants now. C is 1 over 10. Now we'll substitute these values into either equation 1 or 2 so that we can get K. I hope you are finding it interesting. So substitute C equals 1 over 10 into, let's use equation 2 now. I know sometimes you may be asking why we always using equation 1. Let's use something different. Into equation 2. Equation 2 says 100 equals K plus 900C. So that will be 100 equals k plus 900 times 1 over 10. 0, we cancel 0 here. Leaving 100 equals k plus 90. If we collect like terms, 100 minus 90 equals k, which means k equals 10. Which implies that k equals 10. So therefore, C is 1 over 10, k equals 10. K equals 10. So we have the value for the two constants now, C and K. Next, let's try the relationship that is connecting these two quantities, R and V. Recall. What are we recalling? That R equals K plus C V squared. R equals K plus C V squared. So that will become R equals K is 10 plus C, that's 1 over 10 V squared. This is the law that is connecting R and V, or the relationship connecting the resistance and the velocity. Now, with these two, with this weapon in hand, or this information in hand rather, we will now be able to solve for what we have been asked to find. Remember, they asked us, they say for what velocity is the resistance is 170 Newton. So when resistance is 170, velocity we don't know. Now, from this equation, we have that R equals 10 plus 1 over 10 V squared. When R is 170, that's 10 plus 1 over 10 V squared. We'll look for, let's clear this denominator here by using 10 to multiply both sides so that it will be easy for us to get V squared. So that is, we now say multiply both sides by 10. That will be 170. That will be 10 times 170 equals 10 times 10 plus 10 times 1 over 10 V squared. 10 will take 10 here. That will be 1700 equals 100 plus V squared. If we collect like terms, to be 1700 minus 100 equals V squared. That's 1600 equals V squared. Or rather, V squared equals 1600. 1600. Now, to clear the square off here, we'll square root both sides. We square root both sides, and it's going to be square root V square equals square root 1600. When you square root a square, what happens? Yes, you are very correct. The square root will cancel the square, leaving us with what? B. And what is the square root of 1600? Yes, you are correct. That is 40. So therefore, the velocity is 40 kilometer per hour. 40 kilometer per hour. Always remember to put a unit if a unit has been given to you. So that is all about this topic. That is all about this topic, variation. If you have followed up from the beginning up to this point, you have no problem at all when you meet any question in variation. We have talked about direct, inverse, joint, and lastly now partial variation. Thank you very much. I appreciate so much. And I hope to see you next time. In our next class, we'll be looking at a different topic, modular arithmetic. I hope you will join me then. Please press the subscribe button. See you in the next class.